Our cities and towns are built over a complex network of underground pipelines, providing the residents of the city with clean drinking water, sewer systems for sanitation, and stormwater relief. Like all things, these pipelines degrade over time and at some point require replacement. The consequences of not doing this can sometimes be catastrophic. This situation has made the job of replacing old pipes challenging, given that digging up established neighbourhoods, communities and roads is not practical and can be very costly. This was exactly the case with the North Georges River Submain, or NGRS, a large sewer pipe and integral component of Sydney Water's sewer system, which was in need of replacement. So how do you replace an existing pipe below ground without digging up and disrupting the environment on the surface above? One way is to replace the existing pipe by installing a new, smaller pipe inside it and using existing manholes for access. The challenge in this case was that the NGRS pipe was 2.5 metres in diameter and the distances between manholes was very long, some over 700 metres apart, making it one of Australia's biggest sewer pipe in existence. For this particular project, Interflow used ribline pipelining technology developed by Sekisui Riblock Australia. Ribline is a steel reinforced plastic composite that can be produced inside an existing pipe by a machine that is lowered inside an existing access chamber or manhole. The equipment required to produce the new pipe is mobilised and assembled above an existing manhole. Setup is fast, and because existing manholes are used as access points, there is usually no need for any open excavations. Once the setup above ground is complete, the pipe producing machine is lowered into the access chamber and is ready for producing the new pipe. The new pipe is manufactured using a technique called spirally wound. This process involves feeding a composite strip of steel reinforced plastic profile from a spool above ground into the machine in the manhole below. The machine then drives the composite profile around a set of rollers inside a circular cage. The composite profile takes the shape of the circular cage. At the same time as this is happening, the machine permanently joins adjacent profile strips together by applying an extrusion weld at the edges. The new pipe is produced at a slightly smaller diameter than the existing pipe to allow it to fit through the existing pipeline. As the pipe is produced, it continually rotates and corkscrews its way forward, getting progressively longer in length. The entire process is performed whilst the sewer is still flowing. This process is complete when the new pipe has reached the next manhole. In this way, the existing pipeline is renewed in sections, from one manhole to the next. In the case of the NGRS project, the furthest distance between adjacent manholes was 706 metres. By successfully installing a pipe over this distance, Interflow had in turn produced the world's longest and largest continuous pipe. Finally, to complete the installation, cement grout is mixed on site and pumped down the pipeline, where it is injected behind the new pipe through grouting portholes. The grout fills the void between the outside of the new pipe and the existing pipe wall and is left to cure. The finished product is a new pipeline that will last for many more decades to come. With this technology, Interflow was able to effectively renew in total over 5 kilometres of NGRS pipeline without having to disturb any of the houses, businesses, roads and parklands on the surface above.